All right, this is Honors Algebra 2 Pre-Calc. We're doing 9.4 in Pre-Calculus, which is proofs by mathematical induction. So we're going to do example 2 now. We're going to prove the statement 1 plus 2 plus 3 dot 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 plus n equals n times n plus 1 all over 2, which is similar to what we learned when we talked about doing sums of arithmetic sequences when we talked about Gauss, right? Another way to look at this right-hand side would be n over 2, which would be the number of pairs, times 1 plus n, which would be the first term and the last term. So this is actually the same exact formula that we learned when we talked about using the sum that Gauss used to sum the first 100 numbers when his teacher asked him to do so, which we talked about in 9.2. So remember our steps for mathematical induction, right? We have 3 steps. So number one, we're going to show that P sub 1, meaning what happens if we only plug in 1, is true, okay? So that's usually a pretty easy step. If you get that P sub 1 is not true, it's usually you, so stop and figure out what's up, right? So if I only plug in 1 on this side, then I only have this term, so my right-hand, or my left-hand side is a 1, right? And the question is, does that equal what happens when I plug a 1 in on the right-hand side? Which would be a 1 times a 1 plus 1 all over a 2. Well, I get 1 equals 2 over 2, and sure enough, that's true. 1 equals 1. So check. I've shown that P sub 1 is true. Second step is I need to assume P sub k, right? So I'm going to assume P sub k is true. What that means is I just rewrite this expression with a k, and then I assume that is a factual statement, because we're trying to show that these are equal. So I'm going to assume that P sub k is true, meaning that 1 plus 2 plus 3 plus dot 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 up to k equals a k times a k plus 1 all over 2, and that's a fact. Okay, so what I'm doing here is assuming that those are true. My third step in induction, and this is the one that's worth all of the effort, right? This is the hard part, is I'm now going to use this expression to prove, or rather show, I mean, we can just say show, just like we said we're able to show that P sub 1 is true. So now we're going to show that P sub k plus 1 is true, okay? And I'm going to have to use this entire expression at some point to do that. So let's look at what P sub k plus 1 would be. P sub k plus 1 would be the sum of all the terms up to k plus 1. So 1 plus 2 plus dot 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 up to k and up to k and then k plus 1, right? Now, there's a reason I wrote what k is, though. And then on the other side, I'm trying to show that it's equal to what happens when I plug in k plus 1s instead of n. So k plus 1 times k plus 1 all over 2, right? So on this side, I have a 1 plus 2 plus dot 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 up to k plus the k plus 1th term, right? And on the other side, I'd probably clean this up a little and make this a k plus 1 times a k plus 2 all over 2, right? And I'm trying to show that these are the same. So now, the big trick in mathematical induction is that this thing that I assume to be a fact, I'm going to take this thing and I'm going to replace it in this spot with this k times k plus 1 all over 2. So this is a k times a k plus 1 all over 2, because that's what I assume to be true in the second step of my induction, plus this k plus 1, right, because that guy wasn't inside that whole thing, and I'm trying to show, again, that it's equal to this whole thing on this side, right, the k plus 1 times a k plus 2 all over 2. Now I'm going to need a little more space for this in a sec, so I'm going to erase some things. All right, so I now need to clean up this left-hand side so it looks like this right-hand side, and then I'm good. Now, there are a few ways to do that. One way I've seen some people do this is by factoring out a k plus 1, which is fine. That's not what I'm going to do here, right? What I'm going to do here is get a common denominator. So I have this k times a k plus 1 all over 2, plus this k plus 1 is over a 1. So I'm going to times it by a 2 over 2 to get a common denominator. And again, I'm trying to show that that's equal to this k plus 1 times k plus 2 all over 2, right? So it seems to me like this numerator is now a k squared plus a k plus a 2k plus a 2 all over a 2. And I'm trying to show that that is equal to a k plus 1 times a k plus 2 all over 2. Remember, I can't do anything to both sides of this because it's a proof, so I don't know that these two sides are equal. It's my job to write them until I get them to be completely equal. So I'm going to slide over here again, and I'm going to copy my bottom step. So the bottom step, if I clean it up a little, was a k squared plus 3k plus 2 all over a 2 is supposed to equal, with that question mark still, a k plus 1 times a k plus 2 all over 2. Well, if I factor k squared plus 3k plus 2, it's going to factor into a k plus 1 times a k plus 2 all over a 2, which is, in fact, exactly the same as the expression on the other side, right? You're done when your two expressions match exactly. So QED, since my first term worked, and I showed that if some kth term worked, the one after it works, I've now proven by mathematical induction that this statement, P sub n, works for any n value greater than or equal to 1.